This is Jalisha, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science for Women, Hosur. Today we are going to see about the mathematical induction topic in discrete mathematics. Mathematical induction. It is a technique that can be applied to prove the universal statements for sets of positive integers or their associated sequences. So, what is sequence? It is a collection of values arranged in a particular order in a set is called sequence. So, in that sequence, if an equation or a property is said to possess for all the elements means how it is going to be proved. That is the process of proving that property for the whole set is called as mathematical induction. So used to prove the statement of the form for all x in P of x where x is taken from the integer set, positive integer set. Here are the mathematical induction steps we are going to follow to prove for all x P of x will be true. The case. So the basic step is the proportion P of 1 is true we need to prove. That is for this x if we are substituting the initial value, the starting value of that set, and we need to show the given condition is true. Next step is we need to assume for nth place value the given statement condition is true, and we need to prove if we substitute the value of x as n plus 1, then also the given statement will be true. If so, finally we can say for all the values of x, the given statement p of x will be true. Here is an example. The question is we need to prove the sum of first n odd integers is n square. So sum of odd integers means 1 plus 3 plus 5 etc. If suppose 2n 2n is the number means you just put n equal to 1, you'll get 2. Then n is equal to 2, 2n is the number. So if n is 2 means 2 into 2, 4. So 2n format will represents an even number. But here we need the odd number set. So odd number means 2n minus 1. What will be the values we are going to get? 2n minus 1. In that n is equal to 1 means 2 into 1, 1 minus 1 that is 0. Okay, then n is equal to 2, 2 into 2. Here if you are substituting n is equal to 2, 2 into 2, 4 minus 1 that is 3. So if you are substituting the n values in 2n minus 1 form, it will represent an odd number. So based on that, the general term is represented here as 2n minus 1 equal to, we need to show it as n square. So this is our statement 1 plus 3 plus 5 plus 7 etc. up to 2n minus 1 will be equal to n square is the statement we need to prove. Okay. For that statement we are giving the name as P of n and the statement is referred. The LHS value is 1 plus 3 plus etc. up to 2n minus 1 and RHS value is n square. What about our basic step? We need to show for n is equal to 1 the given statement will be true. So substituting n is equal to 1 in the LHS of P of n, what you'll get? P of n. Here 1 means the first term alone you will have. So LHS is 1. What about the RHS? Here it is n square. For n, what we are going to substitute? 1. So what you'll get? N square is equal to 1. So LHS already 1 means only one term. The first one is 1. LHS is 1. RHS is 1. So P of 1 is true. What about the next inductive step? P of n is true we need to assume. So P of n is true is assumed. So it means 1 plus 3 plus up to nth term 2n minus 1 is taken means you'll get the answer as n square. That is true is considered now. Now we need to prove P of n plus 1 is true for all n. So let's take the n plus 1 terms. So how it will be represented? 1 plus 3 plus 5 up to the nth term is 2n minus 1. So what about the next term? We cannot consider 2n because it is an even number. Here we are considering only the odd term sum. So the next n plus 1th term here it is 2n plus 1. For example, for 2n plus 1, if you are substituting n is equal to 1, you will get 3 as the answer. So it is representing an odd number. So we have considered the n plus 1 terms in the left hand side. So what about the right hand side? N will be considered into n plus 1 here. So RHS will be in the form n plus 1 the whole square. This thing we need to prove. So for that, we are first considering the left hand side value of P of n plus 1. What is the left hand side? 1 plus 3 plus 5, etc. up to 2n minus 1 plus 2n plus 1 is considered. Now here, for from 1 up to 2n minus 1, we can substitute the value as n square because we have assumed this P of n is true. So true means this value will be equal to n square is an accepted thing. So we are substituting 1 up to 2n minus 1 value as n square plus the last term bracket as it is. Okay, now simplify this. Factorizing this, what you'll get? N square plus 2n plus 1. This is of the form a square plus 2. A is n into b is 1. Okay, so b is 1 again. So this represents n plus 1 the whole square formula. So which is equal to the given RHS. Hence we have proved P of n is true for all the values of n as per the defined values. Similarly, the next problem is we need to prove n cube minus n is divisible by 3 for all positive integers. So here again, P of n is taken as the given statement. What is the LHS? N cube minus n. And actually, we need to show here the right hand side as this value. The answer of n cube minus n should be divisible by 3. Divisible by 3 means what is the concept? Our answer should be a multiple of 3. Should be a multiple of 3. So basic step is we need to take n is equal to 1. So we consider this. So substituting here, what you'll get? 1 cube minus 1, okay, which is equal to 0. 0 is always divisible by all the elements. So 0 is obviously divisible by 3, which is satisfied. So P of 1 is true. Hence, we can go with the inductive step. That is P of n is true, we need to assume. P of n is true means what is the case? N cube minus n is divisible by 3 is the meaning. So we need to prove P of n plus 1 is true. N plus 1 means how this taken statement will be changed. P of n plus 1 denotes n plus 1 the whole cube minus n plus 1 will be divisible by 3. Okay, so this is the thing we need to prove. In that we are considering the LHS. N plus 1 the whole cube minus n plus 1 is considered. Expanding n plus 1 the whole cube value. So for this term, what you'll get? N cube plus 3n square plus 3n plus 1. This is a plus b the whole cube formula we have substituted here. Plus, sorry, here we are having the next is minus of n plus 1. Minus is taken inside. So what you'll get? Minus n minus 1. Simplifying this, we'll get n cube minus n plus 3n square plus 3. Out of the last two terms, we are taking 3 as the common term. So you'll get multiple of 3. What about the first term? N cube minus n. It is assumed that P of n is true. So according to that statement, n cube minus n is divisible by 3 is a known thing. So first part is divisible by 3. The second part is also divisible by 3. Sum of those two will also be again divisible by 3. Hence we have proved the statement is true for n plus 1, which implies for all the values of n, the given P of n will be true. Now here another example we have given n is less than 2 power n for all positive integers n. So our needy thing to prove is n less than 2 power n. For substituting n is equal to 1. LHS is n is equal to 1 means 1. What about the RHS? 2 power n. N if you are substituting 1 means what you'll get? 2 power 1 is 2. So actually here we need to prove less than inequality, not equality. So just compare the left hand side and RHS. RHS should be a greater one, LHS a smaller one. It is satisfied in the first case. So we are moving with the inductive step. Inductive step means n is less than 2 power, n is true, should be assumed, and we need to show P of n plus 1 is true for all n. Okay, so P of n plus 1 means it denotes n plus 1 is less than 2 power n plus 1 according to this P of n. Now we need to show this n plus 1 is less than 2 power n plus 1. So we need to consider n plus 1. Already we know n is less than, see here, n is less than 2 power n. So we are going to substitute the value of n as less than 2 power n plus 1 as it is. Okay, now compare this 1 with 2 power n. Okay, so 1 is the left hand side. We are going to compare that with 2 power n. What is the value of 2 power n when n is equal to 1? 2 power n value will be equal to 2. When n is equal to 2, 2 power n value will be equal to 4. So it starts from 2, 4, 6, 8, it goes on. We are comparing that 2 power n value with 1. So always 1 will be less than 2 power n is obvious. So for 1, again we are substituting that also less than 2 power n. So finally we are having 2 times of 2 power n. Okay. So you see here 2 power n is taken common. So here the remaining factor is 1. Here it is 1. So we get 2 times of 2 power n. Now a power m into a power n formula is applied here. So you'll get 2 power n plus 1. That's what we need to prove. Hence p of n is true for all values of n. Now this is an practice question. It's based on the set notation. Please go through with that. Thank you for watching and patience. Thank you.